Earlier, you learned about the rectilinear motion of bodies. In simple terms, rectilinear motion is a motion that occurs in a straight line. The motion of a body in a straight line is treated as one-dimensional motion. The description of motion of a body involves its position, displacement, velocity, acceleration, and time. In the one-dimensional or straight-line motion of a body, you are able to represent all these entities on a number line. A number line has an origin, and measurements to the right of the origin are taken as positive and to the left taken as negative. By adopting a proper sign convention for all the entities, you are able to solve the problems analytically. Before you proceed to the next topic that deals with two-dimensional motion of a body, that is, motion in a plane, you need to evolve a new way to represent these entities, as the number line method will not adequately describe and represent them. To fulfill this need, a new way called vector representation is used. Before learning this, you need to learn the basics of scalars and vectors. Let us start with scalars. Entities described completely with the help of a number, along with its unit, are called scalars. The mass of an object is 10 kg. This description is complete, and you do not need to add to it to identify it. Similarly, the distance between point A and point B is 20 centimeter. Is a complete description. Likewise, the temperature of a body and the time at which an event takes place are described completely by a number along with corresponding units. A number along with a unit that represents the measure of a physical quantity is called its magnitude. Thus, mass, distance, and temperature are scalars. As with numbers in elementary mathematics, scalars can be added, subtracted, multiplied, and divided. Operations on scalars are the same as in elementary mathematics and algebra, whereas operations on vectors obey the triangle law and parallelogram law of addition. You will learn various operations on vectors one by one in detail. First, let's start with multiplication of a vector with a real number. When you multiply a vector p with a positive number, lambda, you get a vector whose magnitude is changed by the factor lambda. The direction remains the same as that of p. Mathematically, it is expressed as mod of lambda p is equal to lambda into mod p. For example, when p is multiplied by 4, the resultant vector is 4p, whose magnitude is 4 times that of mod p. On the other hand, when you multiply a vector p with a negative number, lambda, you get vector minus lambda p, whose direction is opposite to the direction of p, and its magnitude is minus lambda times that of mod p. For example, when you multiply p with minus 3, you will get vector minus 3p, whose magnitude is 3 times mod p and direction opposite to the direction of p. The dimensions of lambda p is the product of the dimensions of lambda and p. Next, you will learn about addition of vectors by the graphical method. In the graphical method of vector addition, either the triangle law of addition or the parallelogram law of addition is used. Now let us add two vectors by the triangle law of addition. Consider two vectors P and Q lying in one plane. Draw a line AB parallel to P. The length of AB is equal to the length of P. Display an arrowhead at B. A is known as the tail of P and B is known as the head of P. Then draw a line BC parallel to Q and equal in length to Q. Display an arrowhead at C. B is the tail of Q and C is the head of Q. Note that the tail of the second vector always coincides with the head of the first vector. Now, join AC. Display an arrowhead at C on line AC. AC is vector R, obtained by adding P and Q. Similarly, draw a line DE parallel to Q. The length of the line DE is equal to the length of Q. Display an arrowhead at E. Then draw line EF parallel to P and equal to the length of P. Put an arrowhead at F. The tail of P coincides with the head of Q. Now, join DF. Display an arrowhead at F on the line DF. DF is vector R obtained by adding Q and P. Here, vector R obtained by adding P and Q is the same as obtained by adding Q and P. This vector addition is the commutative property of vectors. Vectors also obey the associative law of addition. To understand this, consider three vectors A, B and C lying in one plane. Add A and B to get D. Then add D and C to get R, which is the final result. Similarly, add B and C to get E. Then add A and E to get R, which is the final result. Here, A plus B plus C is equal to R in every case. This proves that vectors obey the associative law of addition.